Hello, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek in my personal experiences. This is a channel that is designed with you in mind. Let us dive into today's lesson. The skill of answering organic chemistry questions is very important if you are to get good marks in your final exams. And I'm bringing in a revision session here. I took this question in one of the previous tests that was written for March, and it's for your grade 12s as you're preparing for your exam. So let's study this question number 5 as you're preparing for your organic chemistry, and it will come handy for you guys. Look at this. Let me minimize this. It says letters A to H in the table below represent 8 organic compounds. So what I'm doing here is I'm trying to prepare you and show you some strategies that you can use in approaching questions in organic chemistry. It's one of the most important sections that are always encouraged. So they're saying letters A to H in the table below represent 8 organic compounds, and you can see there is A here, and we have got B. A is got it's a compound with 1 oxygen, so you can somehow play around such to say it can be an alcohol, it can be an aldehyde, it can be a ketone. All these I've got things that you can think about. Is one oxygen, and then the other one is got branches here. You can see that B is only carbon and hydrogen, no double bond, only single bond, so it's an alkane that is branched. Compound C, this you can see that this is a ketone. While is it a ketone? There is carbon surrounding this group, and you know what is this group? Is the carbonyl group. Those are things that you need to know in general as I'm going through. Then compound D, you can see that it's carbon and hydrogen, but I have a double bond there, which is an alkene. Compound E is 3,4-dimethyl pentanol, and then F is a carboxylic acid, and then G is ethyl ethanoate, that's an ester, and the pentane 3,1 is a ketone. Now look at this thing. Define the term saturated compound. How will you define that? What is a saturated compound? The word saturated there, we can quickly say a saturated compound. Remember, we're in organic chemistry. These are the keywords they will expect for you. Number 1, it's a compound that contains what? They say contain only single bonds between what? Between carbon atoms. That's what they're looking for. It's a compound that contains only single bonds. The keyword there is only single bonds. Or you can use the other definition. Another approach is to say it does not. It's a compound that does not contain. You see, the keyword there is does not contain any multiple bonds. Multiple bonds. By multiple, we are meaning here carbon double bonds, or we are meaning carbon triple bonds. These are multiple bonds. So it's a compound that does not contain any multiple bonds between carbon atoms. All right. So that can be the definition of what? Of a saturated compound. So if you're looking at that, it's a compound that contains only single bonds or does not contain any multiple bonds between the carbon atoms. That is that. Let's look at the next question. That was 2 marks. Write down the following, the letter that represents an unsaturated compound. So the keyword there is what? The keyword is unsaturated. Unsaturated. Remember, we said saturated contain only single bonds. So the letter that contains, we want the letter that represents unsaturated. Now you look for carbon-carbon double bonds, and you can see that D is the one that is showing my carbon-carbon double bonds between two carbon atoms. So the letter there is what? It's D. Next one, it says the IUPAC name of B. Let's look at B, the IUPAC name of B. Now, if you have to look at B, sometimes I encourage students to say it's good to look at the branches in a way that you can draw this as a condensed structure, or if you can read it from here, it's still fine. Let's look at the longest chain. I can move from here straight like that. It will be 1, 2, it is 1, 2, 3. Okay, let me make it big actually. Let's make this thing big. So this is my longest chain. Those 1, 2, 3, 4, 5, 6, 7. If that was my longest chain, you can see that it's got 7. Or I can move in a way, same way like that, but go down. So it would be 1, 2, 3, 4. Then this becomes 5. This becomes 6. So that's not the longest chain. And then I can move also in a way, move the same way and go up. So it would be 5 and this becomes 6. Or I can move this way. Am I right? So it would be 1, 2, 3, 4, 5, 6. The other one is 1, 2, 3, 4, 5, 6, 7 in a way. 1, 2, 3, 4, 5. So I can try different ways. I'm trying different ways here, but I'm ending up with 7. So I think 7 is the longest chain here. Yes, 7. So if 7 is the longest chain, let me make it big again so that you can see. So remember, the aim is to identify the longest chain, and my longest chain I'm identifying is this one. This is my longest chain, right? With that, look at this now. I'm going to look at the branches. This is a branch, and we call it what? Methyl, because it has got what? 1 carbon. And then look at it again. This is a branch, and what do we call this? Because it's got 2 carbons, it's called ethyl, right? And again, there is another branch. This is called methyl branch. So we've got 3 branches. Now let's number this carbon. This is carbon 1, 2, 3, 4, 5, 6, 7, right? And then I'm going to number it going backwards, which is going to be from here. It's 1, 2, 3, 4, 5, 6, 7. I always encourage you, as I said, I'm giving you strategies. Write both names, and then you're going to select the right one. Let's start with the one from left to right. So what I have from left to right, and somewhere to right, from left to right, look at this. I have got in carbon number 2, so I will have written it as here. In carbon number 1, 2, 3, so there is 3, there is a methyl, so comma. In carbon number 6, remember numbers, you separate with a comma, so 3, 6, then hyphen, not methyl but dimethyl. There are 2 now. Dimethyl. See, in carbon number 3 there is a methyl, in carbon number 6 there is a methyl, so it's 3, 6 dimethyl. And then from there you put a hyphen. You see there is 4, and then hyphen ethyl, and letter and the number you separate it with a hyphen. So for ethyl, number 7 is what? Is heptane. Make sure that you don't space between ethyl and heptane. So it's 3,6 dimethyl for heptane. Now let's name it now going the other way around from right to left. So in carbon number what? It's carbon number 2. So we have 2 comma. So there is a methyl, and also in carbon number 5. So 2 comma 5 dimethyl. Are you with me? It's still the same, di, because there are 2, and then hyphen. Now where is our ethyl? It's in carbon number 4, and then again hyphen. Okay, 4 hyphen ethyl, and then the same word, remember, is heptane. heptane. Must be one word. Remember, you're writing this on a straight line. So let's look at the one that has got the smallest numbering. You add up the numbering. So if I say 3 plus 6, what do I get? I get 9. The 4 never changed. So even if it's 9 plus 4, it is 13. So this one gives me 13. And then 2 plus 5, it's 7. Plus 4, this one gives me 11. So the correct one, there it is. This is 2,5-dimethyl 4-ethyl heptane. Now, is it the right one? Not really, but we have to follow the way they want us to name it. Let me write now the full name. The full name also considers the alphabetical order. It will become 2. Okay, actually the alphabetical order doesn't start. Remember, methyl, M and E, E and M. So it will be 4-ethyl. Why? Because ethyl starts before methyl. And then hyphen 2, 5 hyphen dimethyl. See that? And then as one word, heptane. Then this becomes the name. Are you with me? So guys, that's how you name these compounds here. It was a question, I think, question number 5, 5.2.2. We're looking at 5.2.2. Now let's move on. 5.2.3 says letter that represents a functional isomer of compound F. A functional isomer of compound F. Now look at compound F. How many marks is this? It's 1 mark. Now functional, the key word there is a functional, meaning the functional group is changing. Now you must know what is the group of F. It's a carboxylic acid. It's carboxylic acid. Now the functional isomer that changes is carboxylic acid changes with esters. Are you with me? So if you can look at this one, it's CH3, it's CH2, CH2, and then you've got what? You've got CO. Let me do this. It's got COOH. This is what we have. But if I can write it in a way, as I say, it's a functional isomer, just in general, I can save that. I can have that. And then in the next one, this is CH2. Actually, I didn't change anything here, just to show you here. And then after this CH2, I can bring in the C like this and have it like that. Let me check if it balances. And then C, actually it's CO and ester, and then CH3, something like this. If you can check, 3 hydrogens, there is 3, there are 2 there, there are 2. Now CH2H, this is CH3, there is CH3, and then everything is still the same there, right? And then this is what? There is the carbon. Okay, no. There is this carbon is that carbon, and this carbonyl is that carbonyl, so it matches. So that is that. So it is what? It is. The question is, what did they say? They are saying here, letter that represents a functional isomer of compound F. Okay, a functional isomer. There is an ester, ethyl ethanoate. So you just look for an ester. All right. So ethyl. So look at the carbons. Ethyl is CH3 ethyl ethanoate. So it's more like ethyl and ethanol. CH3 CH2OH. Ethyl group is this one from ethane. Sorry, from what do you call this? It's carboxylic acid. It's ethanoate. CO. Actually, it's CH3 CH2OO. H. I think it's like that. But it's 1, 2, 3. Then it's 1, 2, 3. But this is 4. Ethyl ethanoate. Let me check another one if ever I'm missing it. No, that's not the one. That can't be D then. Then it will have to be, I think it's D. Yes, let's circle for D, because look at this. That's the one that is got OOH, 2 what? 2 oxygens, and there is no other one that has got 2 oxygens except this ester. So without going much, it's just 1 mark. So let's just circle that. The answer is G. Then the next one, name of the functional group of compound C. Let me erase that. Name of the functional group of compound C. Compound C. Name of the functional group. What is this one? So you can see that this is a C carbon, carbon surrounding this carbonyl group. This we mentioned, it's a what? It's a ketone. The functional group there is ketone. And then 5.2, this was 5.2.4, 5.2.5, the general formula of the homologous series to which compound D belongs. Let's go and look at compound D, the general what? Formula of the homologous series to which compound D belongs. Compound D is an alkene. So alkenes is what? It's CN. Let's start from the first. Alkanes, you must know the groups. It's better to start with alkanes. It becomes easier to know the alkenes. So alkanes is what? CnH2n plus 2. Then you come to alkenes. You knock out 2 hydrogens, then it becomes CnH. You remove this plus 2, we have got 2n. You come to alkynes. Remember, you're subtracting, so you are more like saying minus 2. So again, it's CnH2n minus 2. See, so the answer there, the general formula is that one, CnH2n. All right. And then the next question is, define the term homologous series. What will you define a homologous series? Homologous series, what is it? 2 definitions you can come up with. Number 1, we are saying a homologous series, it is a group of organic compounds. Apologies for my terrible handwriting. I know it looks like I'm hanging on a tree, but you can see it is a group of organic compounds in which one member differs from the next member by what? By the addition, or by a CH2 group, by the addition, I'm just doing this now, addition of a CH2 group. That is it. Or it is a group of organic compounds having the same general formula. A group of organic compounds having the same general formula. I usually prefer this one. A group of organic compounds in which one member differs from the next member by the addition of a CH2 group. Or a homologous series is a group of organic compounds having the same what? Functional group, or having the same general formula. Alright, that is a homologous series. And then what is the next one? For compound E, let's look at compound E. Let me erase that. There is compound E, 3,4-dimethyl pentane 2-ol. What do they say? To which homologous series do they belong? This is an alcohol, pentanol. So it's alcohol. Alright. And then from there, senses write down its condensed structural formula. So this one, if I'm to write the condensed structural formula here, look at the longest chain, pentane, pent. So it's what? 5. 1, you can do that, 2, 3, 4, 5, right? Pentane. And then the next one is pentane 2-ol. So let's start numbering. Let's say this was carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. We have to erase that, but in carbon number 2, it's pentane. There is the OH. That's where the pentane 2-ol. and then we are done with the alcohol part. Then 3, 4. Then come here, you've got CH3, that's a methyl 3. Then here again you've got CH3. Doesn't matter whether you put it on top here like this, it's still fine, but just out of so that you don't crowd everything, you can do like that. And then don't forget, you need to fill up with your hydrogens. If you don't, they're going to penalize you. So I didn't leave enough space for my hydrogens there. I need to just leave my space for my hydrogens there. Okay, there must be space for the hydrogen. So what do I have? I've got CH, first one is CH3, and then CH, and then even here CH, even here. Now I don't need this guy here. And then 1, 2, CH1. Okay, this is must be 4. Remember, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. So this is CH2 and this is CH3. It must have how many bonds? 4 bonds. Don't forget. Don't forget. So in a way, you can have kind of if you don't want to miss it, to say, let me draw a structural formula just to remind. There is the hydrogens there, the CH3, then there is the CHOH. See that? That's the structure though. This one is fine. CH3 is not a problem, but CH, then there is the C, and then H, and then here is the CH3. There I made an error. It's CH. It's supposed to be 2 there. CH. Alright. So then the last one is C, H, H, and H. So you see, these are my branches. These are my branches. These are my branches. So it's CH here. CH. So that, but the answer here they want is that one, the condensed structure. Alright. If you wanted, you could have done this CH3, and then you're like C. You remove actually these bonds in between. You just write without these bonds, but you can still show the branches. It's still fine. Or you could have done it like this to say CH3 CH bracket OH. They allow it, and then CH, and then from there you put what? If I look at it, CH, and then you can put brackets and CH3, and then close it, CH, again CH3, what, 2, something like that, but don't advise this one. Let's go for this one. All right, makes things easier. All right, then the next one, what do they say here is to say all right, that was that. Let's move on to the next question. It says here is it a primary or secondary or tertiary? Is it a primary, secondary, or tertiary compound? Let's come back here. Suppose, okay, the AT is still there. Lucky I didn't remove the other one, but there it is. Is it a what? What type of an alcohol is this one? This one, if there is a carbon here and a carbon, look at this. If it's primary, it will be at the end, like this. So this is primary. We call it first degree. If it's secondary, it is more like you've got a carbon, and a carbon, and then it's in the center like this. And then here there is H. This becomes a 2 degree secondary. If it's tertiary, it's C, and then you have a C there, you have a C there, you have a C there, and then you've got OH. Then this is tertiary. You see, 3 carbons surrounding the main guy. Here, 2 carbons surrounding the main guy, and then here only there is after that it will be H here, it will be H, and then C. So it will be 1 carbon. So 1 carbon, 1 degree, 2 carbons, 2 degree, 3 carbons. So what is this one called? This is a secondary alcohol. Secondary alcohol. I wanted to write alcohol. This is secondary alcohol. All right. Then the next one is not that. And then they're saying, explain your answer in question 5 point that. How to explain that? From this, actually, that was what I was doing to explain the answer. It is there are, you can actually mention the same thing to say there are 2 carbon atoms surrounding the carbon with the OH group. So there are 2 carbons. So there are 2 carbons, these carbons and those carbons. There are 2 carbons surrounding the carbon with the OH group. I'm trying to explain exactly what I was just doing there. Alright, so that is 16 marks, guys. As I say, it's revision with your organic chemistry so that you can see how you can fare or how you can approach it. Another important part, very important, is this one, question 6, where now we are looking at the trends. Here they are focusing on what? Elena uses 4 organic compounds A, B, C, and D to investigate the effect of chain length. See, chain length on boiling point. The obtained results are shown in the table below. There is A, B, C, D. You can see the chain length here is what? The chain length is getting smaller here. You can see that from 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 1. Alright, then the boiling point there. Define the term vapor pressure. What is vapor pressure? This is what we can define vapor pressure. What do you define vapor pressure as? You need to know such definitions. It is the what? The pressure of the what? Vapor pressure. It is the pressure of the liquid. Okay, no, let's say the gas. The pressure of the vapor which is in equilibrium with its liquid vapor pressure. It is the pressure of the vapor which is in equilibrium with its liquids in a closed container. In a closed container. But I'll say, just grab hold of any textbook, get a hold of this vapor pressure. It's the pressure of the liquid which is in equilibrium with its liquid. The pressure of the vapor. So it will be existing the vapor and the liquid in a closed container. That is called, when you're measuring there, you'll be measuring the vapor pressure. Alright, next question there, without doing much. What are they saying here? They are saying, write down the independent variable in this investigation. For this independent. Look, the independent is what we are changing. Independent is what we are adjusting. Here you ask yourself, what are we changing or adjusting? Is the independent. The dependent is what is okay, I don't want to confuse them, but what are we adjusting or what are we altering? That's the independent. The dependent is the one which follows that change. So what are we changing? You can see that here we are changing chain length. So the independent variable is chain length. There it is. And then boiling point becomes the dependent, because when we change the chain length, boiling point gets affected. Alright. And the next one, state with a reason which one A, B, C, D of these compounds has the highest vapor pressure. You must understand something with the vapor pressure. Vapor pressure increases with a decrease in boiling point. So this is how the relationship is. If you have got like this to say vapor pressure and boiling point, we call it like this, or if it's a straight line, it's like this. There is an inverse relationship. So when the boiling point increases, the vapor pressure decreases. When the vapor pressure increases, the boiling point decreases. So you can see here that if it's the opposite, 64 has the smallest boiling point, which means it has the highest vapor pressure. All right. So, which state with reasons? So you're going to say D has the highest vapor pressure, and then with reasons, and then what I'm going to say, vapor pressure increases with a decrease in what? In boiling point, BP. Or you can say vapor pressure decreases with an increase in boiling point. So you have to just do the opposite there. It's a matter of mentioning the opposite. When one increases, the other one decreases. That's what they wanted you to capture there. Compound D is now compared to pentane. Pentane is an alkane. This is an alkane. And compound A, OH, these are alcohols. Compound A is a what? A is an alcohol. Alright, then they're saying, is the boiling point of A higher than, lower than, or equal to pentane? Now, alcohols, remember, they've got higher boiling points than alkanes, so it is higher than. So the answer that it is this one. The boiling point of A is higher than. And then they say refer to the types. There is this mark. I want you to get these 4 marks. It says refer to the types of intermolecular forces to explain the answer in question 6.4.1. Now, refer to the types of intermolecular forces. You must be very specific to the question. Number 1, tell us about A. What type of this is saying? What type of intermolecular forces? Identify A and pentane. So you can say here the key words. That's what they will be marking you. Number 1, compound A has a weak van der Waals forces. Forces, first is to identify them. And what? And hydrogen bonds. That's what compound A has. It has got weak van der Waals forces and hydrogen bonds. Because you can say because of the what? Of the OH group. Now pentane, on the other hand, pentane has only weak van der Waals forces or London forces. Weak van der Waals forces. Van der Waals forces between its molecules. Between its molecules. Alright, that's the first part. You have identified the type of the what? Of the forces acting on these. Then you can continue to tell us about what? About the energy. Because the question was which compound A is compared to this is the boiling point. They are wanting you to conclude why the boiling point of A is higher than. So the next one is more energy is needed to break the hydrogen bonds, the H bonds in A compared to pentane. So more energy is needed to break the H bonds in A compared to those in pentane. And then you can conclude and say therefore compound A has a higher boiling point, see, than pentane. Try to break it into points, it becomes better. And then write down the general conclusion that can be made about the boiling points of compound A, B, C, and D, what conclusion can you make? We just did. Look at this. The chain is getting smaller, but the boiling point is also getting what? Is also getting smaller. There is a trend. When the chain is getting smaller, the boiling point is also getting smaller. So you can say what? What is they're asking you to say the conclusion. You can say the chain length, general conclusion is that the chain length, actually you can say as the chain length decreases, the boiling point also decreases. You can say the opposite. As the chain length increases, which means you're going up, the boiling point also increases. Right. So, or you can say the boiling point increases with the increase in the size of the molecule. You see, this is a smaller molecule from the bottom. It's a smaller molecule, but as you go up, the molecular size increases. So the boiling point increases with the increase in the molecular size. So guys, that is what I wanted to bring to you, but I'm bringing in these just to give you kind of a revision so that you can see how you can work around these as you prepare for your final exams. Guys, if you are benefiting from these channels, please remember it is important for you to subscribe so that we can know that behind this channel there are some of you who are benefiting. We have come to the end of our lesson. Thank you.